Okay guys, today's lecture is about rotational motion and how rotational motion affects the motions of different objects. To understand rotational motion, first of all you need to understand the difference between the rotational motion and circular motion. To understand that, I'll take a simple example in which you may know already by now, which the earth rotates around the sun. I'll take the sun here and earth will and this is the axis of rotation. This is somewhat tilted to the sun, and actually there are two motions you can see here. One motion is the rotation of the earth around its axis, so I'll call this as the axis of rotation. Axis of rotation. And while rotating around its axis, the earth goes around the sun. So rotating about its axis, rotating about its axis is called the rotational motion. And the sun is a fixed point because it's a fixed point. Fixed point. And rotating, the rotation of an object around a fixed point, around a fixed point, around a fixed point is called the circular motion. So this is circular motion. All of you must know the difference between the rotational motion and the circular motion in order to understand what is meant by rotational motion. Because most of you guys confused when making sums as to how rotational motion and circular motion differ by each other and how we can apply the theories, the equations and the other stuff in order to solve those problems. Okay, so this is the difference between rotational motion and circular motion. And to understand rotational motion, we have to define what's meant by the angular motion. Actually, angular motion is the sum of circular motion, and the rotational motion. Now we discussed the difference between circular motion and the rotational motion and how we can apply these two theories in order to make your sums easy, and also how to solve the sums with the case when you are given the data in some questions and how can we solve those. So we know the difference between these two, but in order to understand each instance, say this rotation, you need to understand about rotational motion or you need to understand about circular motion, you have to know what's meant by angular motion and what affects angular motion. So in order to understand angular motion, we have to define four characteristics. Those four characteristics are, first one is the angular position, the second one is the angular displacement, the third one is the angular velocity, and the fourth one is angular acceleration. So I will define those stuff one by one in order to understand what is meant by angular motion, and then I will focus on what is meant by rotational motion, and I will explain the theories, the equations and some examples in order to understand what is meant by rotational motion. So okay, first of all, what is meant by angular position? Now you guys may know what is meant by a position in translation motion. Translation motion is the motion in which an object moves in translation. Say, you have an object like this, in some mass, and you give a force F here. And it goes here. Let's say this time equal to 0. This time equals T, and the distance between the two center of masses is T. So what I've actually done is, this is an object. I say the initial velocity is 0, u equals 0. Let's say u equals 0, and here u equals v. Sorry, velocity equals 0. Here v equals, let's say, something like v1. So what I actually done is the translation of this object. Translation of this object from this position. I'll say A, and I'll say this position B. I have transformed this object from this position to here. So this is called translational motion. That does not mean that the translation motion can only be applied to objects which are starting from rest and given some force, and it accelerates and achieves some velocity in a specific time. Translation motion is also a motion that can affect objects which are in constant motion or constant velocity. So actually what happens is, in translation motion, an object takes this position initially, this is the initial position, and under some circumstance at constant velocity or under some force it's accelerating, or it could also decelerate, that means decrease its velocity in a given unit of time. However, in any instance it translates from one position to another. So this is translation motion. So what's the angular position? Now first of all, this is position A, this is position A, right? And this is position B. So in translation motion, you have changed the position of the object. Position of the object is the place in which it plays in the space. So in translation motion, you have translated the object between two positions. So what's the position in angular motion? It is called angular position. Okay. To understand that, so first of all, before explaining what is the angular position and the angular vector quantities, you may already know what are the differences between vectors and scalars. Vectors have a direction and magnitude both, but scalars have only a magnitude. So before defining what's meant by these angular vector quantities, there's an angular displacement, angular velocity, and the angular acceleration, and also to define all those we need the angular position. We will understand, and sometimes it will be confusing to you, that both the rotational and circular motion are to be understood as moving, as if an object is moving, from one position to another in a circle. So this may sometimes be confusing to you if you are not well versed with this subject, and if you are not well versed with circular motion and the other concepts. But in order to understand, you need this concept, and if you are a beginner in this course, and if you are a beginner for rotational motion, you will get to understand the correlation between the angular motion and rotational motion as my lecture continues. So first of all, I will take an object in. You don't need actually the mass, right? In, which goes around the circle like this. Circle, but goes around a circle. And I take the positive, this is as the origin of this circle. So this is actually what is meant by this is the x and y coordinates, the Cartesian plane. I will not draw the y-axis, but I will draw only the x-axis because I don't mean a two-dimensional motion. It's actually a three-dimensional motion, but I am drawing a two-dimensional plane. I'll draw only the x-axis, and I will call this one the initial position. I say this position as A, which is the initial position. And if I select something like this, if I select a point, a general point, now this is horizontal. Now this is horizontal and this is vertical. So I will not select as horizontal and vertical direction because it's somewhat biased to be defined by that. I will take a general point like this. I tell this point as B. Take this point as B, and then I say that the angle between this point and this axis, the positive x direction, this is the positive x direction, is theta. So the angle position of a particle is the angle theta, or any angle theta, phi, alpha, or anything made between the line connecting the particle to the positive direction of the x-axis made in the counterclockwise direction. So that may be too fast for you sometimes, but I'll explain it in detail. So this is the positive direction of the x-axis, and this is the position of the particle. Now we actually transform, you can make differentiate, and you can neglect the position, the translation of the object. Here I've just taken a position like this, and as I mentioned about, the angular position is the angle, some theta or something. I have taken theta here. Angle theta made between the positive direction of the x-axis and the line joining the particle to the center in the counterclockwise direction. So this is the counterclockwise direction, or sometimes it's called anticlockwise direction as well. So this is the angle between this is the positive x-axis, and this is the line joining the particle to the origin. So this is called the angular position. Angular position. Right? So this is the angular position. And what's angular displacement? Angular displacement, if you displace the subject by some degree here, say subject is here like this, I'll call this one as theta I. Theta I. Right? Is it clear for you? Alright. I'll call this theta I, which is the initial theta or the initial angular position, and displace this object take this object here. And I'll call this angle. So this is the counterclockwise direction, this is the counterclockwise direction. I'll call this angle theta f, is a final direction. Alright. So what's the angular displacement? Now you know, if this is an object and this is the initial position, I say this one has the initial position P1, position 1, or Pi position initial. And if this is the final position, Pf, the displacement is the shortest distance between 2 points. 2 points means I will take the center of mass to be prime, so it will be very easy for you, even if the object is asymmetrical or something like that. This 3D space actually I am drawing in 2-dimensional paper. So the position, this is the translational motion. Now, to be frank, to be to make it easy for you, I'll always tell you that for the first part of this lecture and the other definitions on rotational motion, I'll tell you that you should always make the analogy between translational motion and rotational motion, because it's easy for you. Even if you are a beginner or if you are an advanced student who is studying on rotational motion and who has some problems on rotational motion, you should understand that it's always easy if you make an analogy between translational motion and rotational motion. So for the first set of definitions, I'll always use the analogy between translational motion and rotational motion, and in the next sets, those are the somewhat complicated sets of equations and theories. I invite you to make the analogy between translational motion and rotational motion yourself and understand. I will not, in the second part and second and third and the other parts of this lecture and this series of lectures on rotational motion, I will not explain the positive correlation between the translational motion and rotational motion, and you should understand it by the concepts you have understood in the first parts of these lectures. So this is angular position and this is angular displacement, angular displacement. So in translational motion, the displacement is how the distance it moves in a given unit of time. So this is t equals 0, right? And this is t equals t. So within a time t, it has moved a distance t. So this is the angular displacement. But if you are making it, this is a translational displacement, or the normal displacement we have been talking about in Newton's laws and the other concepts of motion, straight line motion. And in angular motion, it's the same. If you had a displacement, initial displacement of theta I, and if you displace this object along this path, along this path to here, right? So the line connecting the 2 points, the shortest distance between these 2 points is the translational displacement. So this is the angle theta I and this is the angle theta F. Unlike in translational motion, we define the position of the particle by its angle, not by the length it travels in a straight line. So if we are to define the angular displacement of an object, it's similar. Similarly, we have to use the angle it makes between the initial position and the final position. So this is the angle between the initial position and its final position, and I will call it theta. So theta equals theta F minus theta I, regardless of the direction, regardless of the magnitude, and theta equals theta F minus theta I. So theta is called angular displacement. I will take angular displacement. I take this one as t equals 0 and this is t equals t. So within time t, it has displaced from a position of angle theta I to a position of angle theta F, and the angular distance it has traveled is equal to theta F minus theta I. So the angular displacement of the object within time t is theta, and it is equal to this angular displacement, this angular position, this difference between the two positions. Okay, similarly, what's angular velocity? I don't have to draw diagrams and show you what angular velocity is. You know what's displacement, what's translational displacement, what is translational velocity, and what's translational acceleration. So in order to understand that, so what's angular velocity? Angular velocity is the same as translational velocity, regardless of the in angular velocity you take only the angle. If the object is going from here, say, and from this position to this position, this is D, right? This is D, and the object here, this is V1, V2, maybe V2 is greater than V1, or V2 may be less than V1, or V2 may be equal to V1. We don't need that, but only thing is that V2 minus V1 or delta V, I call it delta V, right? Delta V should equal to D, and so this is T equals 0, this is T equals T, should equal to D by T. Clear? Alright, so the velocity, the translation velocity, I always call this as the translation velocity and angular velocity because it may be confusing to you sometimes still, and sometimes I am talking about the angular velocity or the translation velocity, and as the lecture continues we will easily get accustomed to that. Now here it is translation velocity. The difference between the two velocities of the translation velocity is equal to the distance traveled by time. Right? Okay. So it's in angular velocity is the same. If you take an object and if you go from here go from this point to this point, from this point to this point is the same, and the angular velocity is the difference between theta f minus theta I is the difference between the distances where the time taken. So this is equal to delta omega actually. Omega is the notation for angular. Omega is the notation for angular velocity, but I will always call this as not delta omega. Right? I will call this as omega because it's the delta value is used later to understand another concept, rotational motion. I will say this is as omega. Omega equals theta, minus theta is equal to theta. This is equal to omega equals theta by t. Similarly, angular acceleration alpha equals omega by t or theta by t squared. Right? So that's the first part of this lecture, and I talked about in this lecture as to how the rotational motion differs by the circular motion and how rotational motion can be defined using the angular motion, and what are the quantities in angular motion that you can easily understand so as to understand the concepts in rotational motion and circular motion. And we defined 4 points. Those are the angular position. The second one is angular velocity, angular displacement. The third one is angular velocity, and the fourth one is angular acceleration. So all these vectors and angular position are correlated with the rotational motion, and I will discuss those concepts in the next lecture. See you then.